All right, everybody did very well in this. One little uh, possible glitch, but the basic idea is very solid. Everybody knows how to do this. Okay. One thing you got to be careful of. A couple of things you got to be careful of. Okay, let's take the first one. Now, the way I usually explain this. Oops, it's f of 2, isn't it? F of 2 equals 3 times 2 minus 1 over 2. Okay. And all we've done is we've just replaced x everywhere in the definition of the function by 2. That's all there is to it. And then we have to evaluate it, of course. And there's plenty of other stuff that we do with function notation that you encounter in pre-calculus. Right now, we just want to get the basics down. Okay, so we have f of 2 equals 3 times 2 minus 1. And that's 6 minus 1, which is 5 over 2. Make sense? Okay. Now, what's f of 1? Well, f of 1, we replace x by 1. That takes care of this f of 1. We've got a plus sign here, which we haven't done anything with, right? So we got to do a plus, and then f of 1. What's f of 1? Well, we just saw that it's 3 times 1 minus 1 over 1. Okay? So there's nothing mysterious about what goes on here. F of 1 is one thing, we can evaluate it. F of 1 is the same thing. We've got a plus between them, right? So we add these two. And of course, 3 times 1 minus 1 is 2. Divided by 1, we get 2 plus 2 equals 4. Okay? It's down to just, everybody knows 2 and 2 is 4. Okay? But getting there, you got to be careful with the function notation. That makes sense? Okay. Okay. Then f of 3 plus 5 equals what? That's f of 8. Because, of course, by the order of operations, we add the 3 and the 5 before we do anything else. It's in parentheses. It means whatever's in parentheses is, okay, it's 3 plus 5. It's also 12 minus 4. It's a lot of things, but it really is most simply just 8. Okay. Now it's f of 8, and we know the pattern for this function. We get 23 over 8. Okay. I didn't check all the answers, but everybody was substituting correctly. So the one thing you don't want to do is think this is f of 3 plus f of 5. Well, f of 3 is 8/3. And f of 5 is 14/5. And that equals 40 plus 42, 82 over 15. You can check my arithmetic on this. We can do it in my head, okay? 82 over 15. And that's certainly not the same as 23 over 3, right? So this is not equal to 23 over 8. So proven that f of 3 plus 5 is not equal to f of 3 plus f of 5. There's no distributive law for f of. There's no distributive law for function notation. This is not multiplication. It's substitution, okay? It looks a lot like multiplication, so it looks like this ought to be true. But this ought to equal this. If you are used to seeing multiplication in your eye, which you probably are, because we've done a lot with the distributive law, right? But it doesn't work that way. And we just proved. Now, there are some functions. If f of x is a linear function, if instead of 3x minus 1 over x, it was 3x minus 1 over 10, for example, that would be a linear function. And if you do it this way or you do it this way, you get the same thing. But that only works for linear functions. It doesn't work for any other kind of function. Okay? So this isn't a linear function. It's not like an mx plus b. Okay. Just want to warn you about that. Don't make that mistake. Okay. You'll be happier if you don't make that mistake. Now, where's the board that I want to use? Here it is. Okay, now we want to go ahead and do the quadratic function. Did everybody recognize this as a quadratic function? Maybe not, because you're thinking, okay, I got to do substitution notation. There it is. Substitution notation, function notation. I've got to do substitution, right? And that's what you're focused on. But let's just observe that this is a quadratic function just for whatever it's worth. Because you want to be able to recognize quadratic functions, even if it doesn't matter, as in this case, that the function is quadratic. As far as evaluating the function, it doesn't matter a bit. Okay. Now, if you're going to get into the properties of the function, which you might with the function notation, then it would matter that this is a quadratic function. We'll see in a minute. Okay, so you've got f of x is negative x squared minus 32x plus 6. So what's f of 2? Well, we write negative, and then we write 2 squared. We don't do negative 2 squared. It doesn't say square the negative. It says square the x and then do the negative, okay? That's by order of operations. This is exponentiation, and negative signs like multiplying by negative 1. So it's like you do the exponent, and then you multiply by negative 1, okay? So it's negative 2 squared minus 32 times 2 plus 6. And at this stage, everybody's good. You're going to have minus 4 minus 64 plus 6. And that comes out negative 62. If I did my arithmetic right. Okay. I don't even bother to check some of my arithmetic if I'm not going to use the result later. So anything that I do with arithmetic, be skeptical. Go back and check it out if you're not sure. If you got something different than negative 62, then either I did something wrong or you did, and you can figure it out. Okay. But if you did make a mistake, it's not at all a problem. Okay, you can fix it very easily because, as I say, everybody's doing the right stuff here. Okay, except maybe me. F of 1, well, actually, that's negative of 1 squared minus 32 times 1 plus 6, which is negative 1 minus 32 plus 6, which is negative 27. And then f of 2 plus 5 equals f of 7, which equals negative of 7 squared minus 32 times 7 plus 6. Now, why did I make myself work out big numbers? Okay, well, it's all right. So that's 210 and 14 is 224. Negative 224 plus 6 is negative 218. And then I'm going to have a negative 49. And that's negative 266. Wait a minute. I'm losing it. Wait, 267. Big question mark on that. Maybe that's right, maybe it isn't. But I don't think it's far off. Okay. And there's at least a 50-50 chance I got that right. Okay. There it is. Also, you could check. It's quadratic, not linear. So there's what we have. Okay. That makes sense? In terms of what I did before. Remember down here, we evaluated this function for 3 plus 5, and then we did for 3 and 5. We got some totally different things. It's not linear. Remember, linear function has to be expressible as just y equals mx plus b, or f of x equals mx plus b, or some equivalent form. Okay, you can't have an x squared. But that idea of linearity is important. It's worth storing away. I'm not going to test you on it. Although I might, for example, on the exam, give you a linear function and a nonlinear function and ask you to test which one. Like, is f of 3 plus 5 equal to f of 3 plus f of 5? Because a linear function is going to be. For the other function that isn't linear, it's not going to be. That makes sense? You can do that. I mean, if I stated that problem right now, you'd be able to solve it. We've got other things we need to do today, but you know, we'll do some reviewing next week and we might work one like that out. Okay. So I don't think you would find that difficult at all. That's kind of an important idea. Okay. Since we have a quadratic function here, and since, did I talk about graphing quadratic functions? I did last time, right? Axis of symmetry and all that stuff. Okay. So I'm going to just kind of reinforce that a little bit because it's going to be very helpful to you when you get to pre-calculus. Okay. First place people tend to have a big stumble in pre-calculus is when you're dealing with quadratic functions and graphing them. Okay. And y'all did well with that last time. So let's see how you are. Just a quick review. Okay. Before we even start to make a graph, and people will make a graph and then they'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the x-axis and negative 1, 10, because that's kind of all you learn about graphing in most of the prerequisite courses, if you learn that much. Okay. As I say, there's just a whole lot of material that goes into these prerequisite courses. And in my opinion, you've got too many students in those courses who are never going to learn it. But you have to teach them and they have to pass the course. You as a teacher are really between the rock and the hard place, and things end up being left out. and the harder things end up not being covered. And that's a big disadvantage for students who are going to go on. Okay. Some teachers manage to accomplish that by choice of what they cover and what they don't. But there's always something that gets left out, and this could be left out, okay? And it's choices. It's not teacher's fault. So anyhow, you graph f of x. F of x is quadratic. So let's see what the quadratic formula tells us. Let's find the zeros. I put this in function notation. We want to solve f of x equals 0. Okay. So I'm going to ask you to just get a start on that. F of x equals 0. F of x equals this. So f of x equals 0 means this equals 0, right? And then you can use the quadratic formula because I don't think you're going to factor that. Okay. All right. So everybody did great. The equation f of x equals 0. So since f of x equals this quadratic expression equals 0. So x equals the negative of negative 32 plus or minus the square of negative 32. And then you got the 4ac. It's minus 4ac. And everybody, I think, got this. Minus 4ac. Actually, not everybody did get it. Okay, you got to be careful. Turns out it's plus 24. And some people had a minus 24. That's easy. If you do minus 4ac, let me just note it down here. Minus 4ac equals negative 4 times negative 1 times 6 equals plus 24, not negative 24. Negative signs are the bugaboo that messes up everybody, including experienced mathematicians. Okay, you got to be, it's like bookkeeping. And just because you're a brilliant mathematician doesn't mean you're a brilliant bookkeeper. Okay. So it's very common to have errors in signs, unless you have a mathematician. It's also a good bookkeeper. And that's who you want doing your calculations by hand. Okay. Okay, anyhow, you put this all together and you get 32 plus or minus the square root of 1,048 over negative 2. Well, we can simplify that square root of 1,048. It's could be written as a square root of 4 times 524. Now, why didn't this work? It's half of that. 262. Okay. What I had there was divisible by 4. But that would mean this should have been divisible by 16, and it isn't. It isn't because 1,024, which is the square of 32, is divisible by 16, but 24 isn't. So, knowing a little bit about the structure of the number, we see that we can't divide by a bigger power of 2. Okay. Actually, yeah, A would, but it's not something we take a square root of. Okay. Now, why did I do this? It's because the square root of 4 is 2. And that's going to leave me a smaller number here to take the square root of. Okay. Now, there could be another square that divides into 262, but there isn't. Okay. If you do a prime factorization, you'll find that 4 is the only number that goes into this. I'm not going to get into a whole lot of detail on that. We can then say this is the square root of 32 plus or minus the square root of 4. That'd be square root of 64 over negative 2. And that's 32 plus or minus 2 times the square root of 262 over negative 2. Okay. So now we can start using this information to do some graphing. I'm going to have to trust me on a numerical approximation. And if you have a whole lot of trust in my numerical approximations, you need to be a little more skeptical. You need to check them out. Okay, so now the distributive law tells us that this is equal to this. In other words, the negative 2 divides 32, but it's not done. It also divides 2 times the square root of 262. So this would be negative 16 plus or minus what? Well, negative 2 goes into 2. That gives us negative 1, right? Well, if this is a negative square root of 262, it makes the plus into minus and the minus into a plus. So instead of writing plus or minus, we could write minus or plus. Okay. This will just, the negative will just change the sign of the plus or the minus. And we don't even really have to do that, because if it's plus or minus, we get exactly the same numbers we get if it's minus or plus. Doesn't matter whether we do the minus first or second. Okay, we get the same 2 solutions. Now, I've got to be a little bit careful here. And the square root of 262 is really pretty close to 16. Okay. It's like we got negative 16 minus or plus something that's really close to 16. Now, 16 squared is 256. 17 squared is 289. 262 is a lot closer to 256 than it is to 289. So I'm just going to make a educated guess without thinking too hard about it. I'm going to say maybe that's 16.2. Now, it's not exactly 16.2. It's not exactly any number you can write out. But if we're going to put it on a graph, as we're going to do, then we need a number there. Okay. So that is be either this or that. Now, let's just check it out. Okay. 0.2. Okay. We plug it in here. 0.2 squared is negative 0.2 squared is negative 0.04. That's pretty small. It's like 1/25. 0.02 times negative 32 is what? It's negative 6.4. So if I got something really small here that I don't even worry about, and a negative 6.4 here plus 6, we get like negative 0.4. That's close to 0. Okay. So 0.2 plugged into there gives me a number that's pretty close to 0. So that kind of confirms this solution, and also kind of confirms this, because if I square 32.2, I'm going to get square of 32.2. Okay. And with a negative, it's going to be negative square root of 32. If I multiply 32 by 32.2, it's going to be really close to the square of 32, isn't it? Now I'm pointing to this thing. I said x is negative 0.2. This is negative 0.04. This is 6.4. And then this is 6. You add all that up, and you get like 0.4. Small number compared to the other numbers that we're going to encounter here. If you plug in 32.2, you're going to have the negative of 32.2 squared. Then you're going to add 32 times 32.2, which is pretty close to 32.2 squared, but a little greater. Okay, but that's going to be, yeah, it's going to be a positive. So you add these two up, and they just about cancel each other out. And then you add 6, and you get something that's real close to 0. Okay, you could do that. So if you're inspired, go back and look at what I just said and write it out. Okay. All I'm doing, though, is confirming that these two are solutions. You can plug them into your calculator and do the same thing. Okay, so f of x has these zeros. Now we can start to graph the thing. And from this point, I'm going to graph pretty quickly because it's just kind of a repeat of what we did last time. I'm going to say x is negative 32.2 here. And my 0 at 0.2. Now this does disturb me a little bit because the y-intercept isn't right. So I'm going to stop and think about that for just a second. No more than 30 seconds. Okay, now I just had a little brain glitch there. There are other words for that. But just visualizing this thing wrong. Okay. I haven't done anything that's wrong. All this is relatively right. Okay. These are my zeros, so I got to have points on these vertical lines that go through the x-axis, right? Because the x is the x-coordinate and the y-coordinate is 0. That's what we just found out. All right. Now we've got to graph the thing. We know it's got either this kind of shape or this kind of shape. It's a parabola. It's symmetric. Well, we can find the axis of symmetry. Remember, I've told you that's at negative b over 2a. and that's minus 16. And remember that negative of negative 32 over 2 times negative 1 is right here. That's the negative b over 2a part of the quadratic formula. Okay. And this thing, just you can follow it all the way through. That's the number that's here, 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 and here. And here, you see, it comes out negative 16. So when you've got this number here, you've got the axis of symmetry. And the plus or minus over here means you either go this far on the plus side or this far on the minus side of the axis of symmetry, which puts the axis of symmetry right in the middle. That would be a really good thing to remember when you take pre-calculus. Okay, so here we have a graph, and here's our axis of symmetry at that's getting grotesque. X equals negative 16. I realized I'd forgotten the negative, and then my 16 went on with that. Minus 16. What's an axis of symmetry? The other thing we can get is the y-intercept. Occurs at x equals 0, because x equals 0 is the coordinate of any point on the y-axis. Now, what's f of 0? Write it down on your paper and circle it, and the big dark circle, so I can see what you're saying. Okay, so f of 0 equals what? Well, it equals 6. Everybody got that. And how do we get that? Well, we just take the formula for f of x, right there it is. If x is 0, then this is 0, and this is 0. That leaves you 6. The easiest thing in the world to find for a quadratic function is the y-intercept. You just ignore anything with an x in it, and what you got left is the y-intercept, okay? It occurs at f of 0 equals 6. And that's, of course, the y-intercept. So put a y equals f of 0 equals 6 there. So I'm going to put a y-intercept right here. The reason I put it lower rather than higher is because just a little bit past the y-axis, we've got to go through the x-axis. The thing's going to be pretty steep right here, and we've got to make it into a parabola shape, right? It's going to be hard to do that if this thing's too high. We're not going to be able to see the peak. As it is, if I drew it honestly, I wouldn't be able to see the peak. But remember, this point's a lot closer to the x-axis than it looks. Okay. Now, how are we going to draw a parabola through all this? We could try to draw it like this. But once we get here, which is to the right of the x-axis, there's no way to backtrack and go through this point because this thing is a function. You would fail the vertical line test if you went back on this thing. So we can't draw it like this. We have to draw it like this. We've got a peak here. There's the peak. It's going to come down like this. Okay, and I think everybody's got that down. Some people are drawing nicer parabolas than I do, and I'm really jealous, but I'm going to let you by this time. Okay, no prejudice in your grade or anything. If anything, you're going to draw really nice figures and get really good estimates. And then if you make a little error, I'll be a little more lenient. I won't take the point off for that error. Okay. if it's a question, and do I take a point off or don't I? Well, that was a really nice parabola. Yeah, I'm gonna let that go. So, you know, the style with which you do things can have a slight influence on your grade. I won't let it have too much of an influence. Okay, well, there it is. Okay, well, can everybody draw a horizontal line? Through the peak? I'll note that as soon as we said this line is y=6, we have a scale for our y-axis. And really all we got to do is say, well, if this is 6, what's this? Is it 10 times 6? That would be 60. Well, this isn't 10 times as high as this, right? Is it 2 times 6? Well, 2 times 6 would be about here. Now, according to your own graph, let's see what you would estimate. And don't expect your estimate to be very close. Don't expect mine to be very close either. And I haven't figured this out in advance, so we'll see what happens. Okay. So we have a guess of 16, one graph. We have a guess of 30 on another graph. And if we take an honest guess of mine, let's see, there's 6, 12, 18, 24. I'm guessing about 30. Okay. But I'm way off, and so are you. And I'll explain why. Okay, so we've got y=30. Big question mark on that. Now, the reason 30 is way off, okay? It's like more than 8 times that. The reason it's way off is because I had to squeeze in this 0 here to make it look like it wasn't right on the origin, right? But 0.2 compared to 32.2, this distance has to be about 170 times less than this distance. In other words, this distance should be about 170 times this distance. And you can't even draw that. Now, what happens is you pull this point in closer and closer to the y-axis. Well, between the y-intercept and this point here, it's getting steeper and steeper, right? Can we see that? I draw a picture here. Okay. This point is here and this point is here, then the graph pretty much has to be pretty close to a straight line. Now it's curving a little, but you're not going to see the curvature between here and here. Now, if this point is a lot closer, then this line is a lot steeper, right? Which means that between here and here, the line is going to be really, really steep. Well, it's going to have a slope of like 30. Okay, that will be the slope. If X really is 0.2, it's a little bigger than that, but so things are going to be really steep here. So you're going to have to go way up here to curve around enough to get the maximum here. So in this case, if the graph is like this, it'll look like so. If the graph is like this, with the 0 over here, you have to go way up here before you come around. Okay? The steeper it is here, the further you're going to have to go up. Now, I'm not going to test you on anything like that, but I do think that y'all are doing really well with this and can benefit from seeing how the graphs have to fit the shape of the points that we graph. Okay? And then it's really difficult when this thing gets really close. Okay, well, the point is now, go ahead and plug in the x coordinate, -16, to see where the peak really ought to be. Okay, now I said all of our estimates are bad just because of the difficulty of figuring out just how steep this graph should be right here. Okay? If this point wasn't so close to the y-intercept or to the y-axis, it would be easier to get a good estimate. In this case, it's really hard. And it turns out And some of this is not visible. Okay, so I'll say a little bit more about these pictures here. Okay, the estimated vertex would be at x equals -16, y equals 30. But if x equals -16, y equals what? F of -16, and I think that comes out 258. Okay. And if you didn't get that, work it out again. You should get something pretty close to 258. So this point is -16, 258. Not -16, 30. The scale's off. We think 0.2 is much closer to the y-axis. And we can see what the implications of that are. If this is the y-intercept and this is the 0, then the graph is only about this steep between here and here. If the 0 is like here, the graph is much, much steeper. And the steeper the graph is, the further you got to go up to get to the vertex. Okay, so this graph could have been drawn like this. Now I'm going to have to do my famous vertical leap to get up to 256. And since that's usually accompanied by a sonic boom, I'm going to skip that part. Okay, but it goes way up there, and then comes down, much higher than what our sketch would indicate. Not the fault of our ability to sketch, just the fault of the fact that this 0 happened to be so close to the y-intercept. Okay. Well, that's a lot about the graph, and that's pretty much everything you got to know in pre-calculus about graphing these things. Okay. And that's a real stumbling block for most pre-calculus students. They can't pull that together. So the more you think about this now, the easier it's going to be when you see it in a pre-calculus course. And since y'all are doing really well, I decided to go ahead and do this. Now let's back off and do something related to what you've already seen me do. We noticed that the square root of 1048 is the square root of 4 times 262, which equals the square root of 4 times the square root of 262, which equals 2 times the square root of 262. And you can't make, there's no other square of whole numbers that would divide into 262. Okay, so you can't make it any simpler than that. This is square root of y to the 9th. Well, it's not y to the square root of 9. Okay, which would be y to the 3rd. And there's something else I need to write there. So rewrite this. In that sense, if I square this, I don't get y to the 9th. whatever the square root is, I've got to be able to square it and get what I started with, right? Now, let's just do square root of y to the 8th. I'm claiming that it equals y to the 4th. And of course, your rule for an extra power of a power is you multiply the two powers. Okay. Now I'm going to write what I started to write before. Square root of y to the 9th can be written as the square root of y to the 8th times y to the 1st. And of course, I could just write that as y. I chose to write the exponent explicitly, so you can understand that we're adding the exponents here, and that's going to give us a y to the 9th. All right. And that's the square root of y to the 8th times the square root of y. And that's, since the square root of y to the 8th is y to the 4th, as we just saw here, that's what we get, right? Now let's see if you've made a connection. I'm just going to give you just 20 seconds to write this down. What's the square root of x to the 16th? You should see from the example we did here that the power I get here is half the power that I get here. Why is it half the power? Because when you square that power, you're going to double it, and that should end up with the power you started with. Okay, so when you have an even number, you just take half the power. And then you check it. And that checks. Because this gets you back to the power you started with. So it's pretty simple. Okay. Well, that's what you really have to understand. Okay. That and the fact that if you do the square root of a number, like $360, okay. Now, take 360 down here, take 360 and divide it by 2, you get 180. You divide that by 2, you get 90. You divide that by 2, you get 45. You keep dividing by 2 until you can't anymore. And it's easy to see whether you can divide by 2, because if the number ends in an even number, you're going to be able to divide by 2, right? Now, it doesn't end in an even number here, so we got to divide by a bigger number. We go to the next number, which would be 3. So you divide this by 3, and you get 15. Well, you can divide by 3 again, and you get 5. Well, that's it. Now, since this divides this into this that many times, this divides this that many times, and so forth, 360 must be 2 times 2 times 2 times 3 times 3 times 5. If you multiply these back, you're going to get 360. And think about that. Well, that's the square root of 2 cubed times 3 squared times 5, which is square root of 2 times the square root of 5 times the square root of 2 squared times 3 squared. Okay. Why do I do that? Because I get even powers on 2 and 3, but I've still got the 2 left over and the 5 left over that have odd powers. Okay. That's going to be the square root of 2 times 5 if we want, and actually I want to write that as square root of 2 times the square root of 5 times 2 times 3. Now there's more. I don't have any more board space, and we're 1 minute over time. So I'm going to stop there because I think if you understand this and understand this, you're going to have no trouble doing the homework. Okay. Except there's some higher roots like cube roots and fourth roots, a couple of problems like that. And if you don't get them, don't worry too much about it. We'll talk about them next time. Okay. But if you look at the videos and the explanations from Open Math and understand what I just did here, you're going to be fine. Okay.